Welcome back to the session 7 of the differential equation. In this session we are discussing exact differential equation. In the last session also we already discussed the exact differential equation, but here we are using a new method to solve exact differential equation. We discussed in the last session is that a differential equation of the form of m of x y dx plus n of x y dy is equal to 0 is called exact if it satisfies dou m by dou y is equal to dou n by dou x. This is the necessary and sufficient condition for the differential equation to be exact. In the last session we discussed how to solve this exact differential equation. Here we are discussing a simple method to solve exact differential equation. If equation 1 is exact, then we can have a solution by solution of 1 has integral of m dx plus integral of terms in n not involving x dy is equal to c. We use this formula to find this solution of the differential equation. Terms in n not involving x. That means in our n there are terms containing both x and y, but sometimes some of the terms will come just only in y. That we are placing here. We remove all the terms from the n which involves at least one x is there, or some part of function contains a part of x is there, that will be removed. You can understand that is on the from the next example. Come to the example 1. Example 1, solve the differential equation 1 plus 4xy plus 2y square dx plus 1 plus 4xy plus 2x square dy is equal to 0. Now, this is of the form of exact differential equation. This is of the form of exact differential equation. This stands for m and this stands for n. Now, this is of the form of mtx plus nty is equal to 0. Firstly, we have to check whether our differential equation whether it is exact or not. I am putting our equation as equation number 1. See, we have to check whether dou m by dou y, our m is 1 plus 4xy plus 2y square. We are partially differentiating this m with respect to y. Derivative of 1 is 0 plus derivative of 4xy with respect to y, 4x is the answer, and derivative of 2y square, that is plus 2 into 2 4y. This is equal to, that is dou m by dou y is equal to 4x plus 4y. See, 4x plus 4y. See, I am taking dou n by dou y, dou x, dou n by dou x. See, our n is 1 plus 4xy plus 2x square. Here 1 is a constant, therefore derivative 0, and we are partially differentiating with respect to x. Therefore, as I said you earlier, x is the only variable, all the remaining things are constant. Therefore, 4y is a constant, derivative of x is 1, and x is x square, derivative of x square is 2x, 2 into 2 4x. Now, dou n by dou x is equal to 4x plus 4y. See, dou m by dou y is equal to 4x plus 4y, as well as dou n by dou x equal to 4x plus 4y. That is dou m by dou y is equal to dou n by dou x. Therefore, our equation, given equation 1 is exact differential equation. Our equation 1 is exact differential equation. Because of this is an exact differential equation, we can find the solution by using this formula, that is integral of mtx plus terms in n not involving x into dy is equal to 0. See, what about m? M is equal to 1 plus 4xy plus 2y square, as well as n is equal to 1 plus 4xy plus 2x square. See, we are using this formula, therefore, integral of to find the solution, therefore, solution is integral of the value of m 1 plus 4xy plus 2y square into dx plus integral of terms in n not involving x. See, to n here this 4xy contains the term x as well as 2x square is also contains the term x. That is why we are not taking these to be here. The only term in n which does not involve x is the one only. Therefore, 1 ty is equal to c. Therefore, our solution is integral of 1 with respect to x, that is x plus we are differentiating for y, we are treating as a constant. Therefore, for x square by 2 y plus 2 y square x plus integral of 1 ty with respect to y, we are differentiating 1. Therefore, this is equal to y equal to c. See, the answer is x plus, we can cancel this and this, therefore, 2 yx square plus 2 xy square plus y is equal to c. This is the general solution of the one, is general solution of our differential equation 1. That means, this is a general solution and this c, as we discussed earlier, this c is the arbitrary constant, it is treated like a variable. In this session also we can use the initial value problem also if there exists a initial condition. So, this is a general solution for 1. We can move to the next example. The example 2 on exact equations. The example 2 on exact equation, solve 1 plus y dy by dx is equal to 1 minus x. Now, this is a differential equation, this is not in the form of m dx plus n dy equal to 0. Firstly, we will make this into standard form. I am taking this dx to be here. So, 1 plus y dy is equal to 1 minus x dx, 1 minus x dx. Now, I am taking this 1 plus y dy to be here. Therefore, the equation is 1 minus x dx, 1 minus x dx minus of 1 plus y dy is equal to 0. Now, this is of the form 1 minus x dx plus minus of 1 plus y dy is equal to 0. This is of the form of mtx plus nty. Here m is, see here m is, here m is, what about m? M is the coefficient function of dx, that is m is equal to 1 minus x, and as well as here n is the coefficient function of the dy, that is minus of 1 plus y is there. Now, firstly we have to check whether this differential equation is exact or not. If it is exact, we are able to solve by using the above mentioned formula. Therefore, we have to find out dou m by dou y. Here is no term of y involved, therefore, the derivative is equal to 0. Similarly, we have to find dou n by dou x. In similarly, n does not contains the terms of x, therefore, this derivative also equal to 0. Even if their value is 0, simply we can say that dou m by dou y is equal to dou n by dou x. Hence, the given differential equation, I am taking that as equation number 1. Our equation 1, hence 1 is exact differential equation. Equation 1 is exact. As because of equation 1 is exact, we are able to solve this differential equation by using the above mentioned formula. Our above mentioned formula is the solution of 1 is integral of mtx plus integral of terms in n not involving x dy is equal to c. See, what about m? M is equal to integral of, the value of m is equal to 1 minus x dx plus integral of the value of y, the terms in n not involving x. See, in our n there is no term of x is there. That is why we can take all n to be here, that is minus 1 minus y dy is equal to c. Now, by integrating these terms, we can form the solution of our differential equation, which is exact. Integral of 1 with respect to x minus integral of x minus x square by 2 plus integral of minus 1 with respect to y, that is y minus y, integral of minus y with respect to y, that is minus y square by 2 is equal to c. Now, this is the general solution of the 1, and we can take an LCM. I am taking this as x square plus y square, I am taking 2 as LCM. Now, we can take to be here, I removed the minus sign of x as well as minus sign of y square. Therefore, the plus sign is shifted into minus sign. Now, plus x will be minus x, 2 will come with x, therefore, minus 2x is there, and as well as 2 will come with y, because of minus sign, that will be plus 2y whole divided by 2 is equal to 2c. So, we can say that x square plus y square minus 2x plus 2y, for the simplicity I am taking c star or c dash, or simply we can take it as c is a general solution of given differential equation 1. Remember that equation 1 is exact. Because of exact differential equation, we are solving this pattern. Now, we can move to our example 3. Example 3. Solve the initial value problem. IVP y minus 1 dx plus x minus 3 dy is equal to 0, where y of 0 is equal to 2 by 3. I am taking that itself as a equation number 1. Now, see the question here, one initial condition is key. Because of initial condition, we are able to find out a particular solution for the particular value of y at the point x is equal to 0. This means a value of y is equal to, whenever x is equal to 0, value of y is equal to 2 by 3. See our question, this is mtx stands for n and this is stands for nty equal to 0. So, m is equal to y minus 1 and n is equal to x minus 3. See, dou m by dou y, we have to check whether our differential equation is exact or not. To check whether, we have to check dou m by dou y as well as dou n by dou x. If they are equal, we can say that our given differential equation is exact. So, dou m by dou y. is equal to, we are differentiating partially with respect to y, here only y is there, therefore, value is 1, and dou n by dou x, we are partially differentiating with respect to x is only there, is equal to 1. So, simply we can say that dou m by dou y is equal to dou n by dou x. Therefore, equation 1, the given differential equation is exact, as because of 1 is exact, we are able to solve our differential equation 1, with respect to by using the above mentioned formula. What about the above mentioned formula? Integral of solution is integral of mtx plus integral of terms in n, which does not involve, not involving x dy is equal to c, what about mtx? M is the y minus 1. Therefore, we can write this as integral of y minus 1 dx plus integral of terms in n not involving x. The first term is x, which involves x, the second term is minus 3, which does not contain x. Therefore, here the minus 3 only remains there. The minus 3 dy is equal to c. See, we are integrating with respect to x. So, integral of y will be y into x, integral of minus 1 is equal to x plus integral of minus 3, we are differentiating we are integrating minus 3 with respect to y. Therefore, this is equal to minus 3y is equal to c. Now, this is the general solution for 1. Now, this is the general solution, for equation 1 for 1. Now, our equation 1 is a initial value problem. Our equation 1 is a initial value problem with the initial condition y of 0 equal to, y of 0 equal to 2 by 3. So, we will apply the initial condition in this general solution to find out a particular solution, So, to find particular solution, apply initial condition in general solution, By the initial condition, we know that whenever the value of x is equal to 0, value of y is equal to 2 by 3. So, we will apply here whenever the value of x is equal to 0, y is equal to 2 by 3 into 0 minus x is equal to 0 minus 3 into 2 by 3 is equal to c. So, this whole part will go on and 3 and 3 will go on, this is minus 2 is equal to c. Our value of c is minus 2. Therefore, our particular solution is y x minus x minus 3y is equal to value of c. Value of c is, we found it is at minus 2. So, the particular solution is y x minus x minus 3y, we can take maybe minus 2 be here for the convenience, is equal to 0 is a particular solution. And this is a general solution of 1, and we found this is a particular solution. This particular solution because of this initial condition, since our problem is a initial value problem. So, as we discussed in all the examples above, there all if there exists a initial condition, you can find out a particular solution. So, while drawing, you can draw the figures in xy plane. The solution, this is a bunch of curves is existing for the different values of c, but this is a single curve is there in xy plane. See, we can move to the next example, our example 4. We can move to example 4. we can move to example 4. See, example 4 is just an applied question. Consider the equation x y square plus b x square y dx plus x y plus x plus y into x square dx is equal to 0. Given that this equation 1 is an exact differential equation. In our question, we have given that it is an exact differential equation. We have to find the value of b. Find value of b. Using that value of b, find the general solution. Using that, find general solution. Using that value of b, find general solution. See, x y square plus b x square y dx plus x plus y into x square dx is equal to 0 is actually our equation. This is of the format of our mtx plus nty. This is of the format of n dx plus n dy equal to 0. Now, we have given that is exact. We have given that is exact. Because this is exact, we know that the condition of the exact differential equation. What about the condition of exact differential equation? Dou m by dou y is equal to dou n by dou x. Therefore, given that this is exact, therefore, this will happen. So, see, find, we have m is equal to x y square plus b x square y. Therefore, dou m by dou y, is equal to the differentiate this with partially with respect to y. X is a constant and y square, derivative of y square, that is 2y, plus b x square into derivative of y, that is 1. This is dou m by dou y, and we can find, we have n is equal to I am multiplying the x square to b both the parts, x square into x, x cube plus x square into y, y x square is there. Now, we are differentiating n with respect to x partially. Derivative of x cube, that is 3 x square. Derivative of y into x square, derivative of x square is 2 y x is there. See, we have given that one is exact. Since one is exact, dou m by dou y should be equal to dou n by dou x. Therefore, since dou m by dou y is equal to dou n by dou x, what will happen? This is this 2xy plus bx square is equal to x square is equal to 3x square plus 2xy. See, here is 1 2xy is here, here is 1 2xy is here. After all, we found that bx square is equal to 3x square. From this, we can identify that the value of b is equal to, now b is equal to 3. We found that the value of b is equal to 3. Since b is equal to 3, our m is replaced as this is m is equal to x y square, and value of b we found that 3 plus 3 x square y, m is equal to x y square plus 3 x square y. See, this is given that this is exact. Because that is exact, we can show like that integral of solution is, what about the solution? Integral of mtx plus integral of terms in n not involving x into dy is equal to c. Say integral of mtx is integral of the value of m is x y square plus 3 x square y dx plus integral of terms in n not involving x. See, to n here first term contains x cube and second term contains x square. None of the term is available without x, therefore, this is 0 dy. 0 dy is equal to c. So, we can integrate with respect to x, therefore, y square is a constant, integral of x is x square y square by 2 plus integral of x square is 3 x cube by 3 x cube by 3 into y plus integral of 0 is 0 is equal to c. We can cancel 3 and 3 is here. So, after all we will have x square y square by 2 plus x cube y is equal to c. This is the general solution. Maybe we can rewrite this as x square y square. I am taking this 2 to be here, 2 x cube y is equal to 2c. 2c I am writing as a c is some other constant c, just we think that that is a new constant c, and this is a general solution of given differential equation 1. See this is just a method, some of the values we can find by using the concept of exactness, and we found the general solution of the given differential equation 1. And now, there are many more questions relating to this one, and you can solve that questions by using the concept of exact equation. Now, the concept of exact equation is a very useful in many of the applied mathematics, in physics, and most of the applied sciences are using the concept of exact differential equation. Thank you for watching the videos. Thank you. Keep watching the videos. Thank you very much.